All right, y'all. So today we're going to talk about the special cases for your equations. So remember, when we talked about this in class, you're going to do everything the same as every equation that we have done. The only difference is that sometimes things look a little different at the end, and that results in a different answer. Okay. So again, remember, just to make sure our steps are good to go, our first step is always to distribute if necessary. Our second step is to combine like terms on each side. Okay. Our third step is to get the variable to the left. And then our last step is always to solve the equation. Okay. So for number one, I'm going to start with my distributive property. So that gives me negative 8x and negative 4. And this is a negative 8x and negative 2. Okay. So what we've got here is there's nothing to combine on each side. All right, but now I'm going to start solving like normal. So I would normally add my 8x to both sides, and it would cancel over here. Normally, this wouldn't cancel, but today it does. So that just leaves me with negative 4. So notice my variables canceled on both sides. And I am left with a false statement. Negative 4 does not equal negative 2. So the answer to this problem is no solution. All right, I'm going to do the same thing over here. I'm going to distribute my 3 first. 3 minus 9x minus 8. Okay, now I can combine like terms this time. 3 minus 8 is going to give me a negative 5. And then from there, we're going to do our same steps. So I'm going to add 9x to both sides. And when I do that, it cancels over here. And it cancels over here. And this time I'm left with negative 5 equals negative 5, which is a true statement. So our answer here is infinite solutions. All right, so again, on both of these examples, notice your variable canceled out on both sides. If your variable does not cancel out on both sides, you're going to get a regular answer. X equals 5, x equals negative 3, y equals 4. Okay? But if your variable cancels on both sides, it's either no solution or infinitely many solutions. Okay, this is the symbol for no solution. For infinitely many solutions, a lot of times I'll just put IMS as an abbreviation, but it means the same thing. Okay. All right, so we're going to do just 4 problems, short notes today, just 4 examples. Okay, so I'm going to start number 1 with my distributive property. Combine my like terms. And then start rearranging. So I'm going to move my 3x. Boom, boom. Come down. 6 equals 6, but my variable's canceled. So I have no variable left. This is true. So my answer is infinitely many solutions. Okay, number 2. Distributive property is just multiplication, y'all. Know your negatives. Negative times a negative is a positive. Positive times a negative is a negative. Nothing to combine, so I'm going to move. I'm going to subtract 14x. It doesn't cancel on this side, so we are going to have just a regular equation. So that one, it didn't cancel, so we ended up with just x equals a number. All right, number 3. Same thing, start with your distributive property. All right, don't get confused on number 3. I'm going to add my 18x. So again, they do not cancel on both sides. So I keep solving like normal. Add my 24. Oh, they did cancel, but I've still got an x. You've got an equal sign, and that just makes that 0. So now when I divide by 58, my answer is 0. All right, so the last one on our notes, again, distributive property twice here. Signs. Negatives and negatives, positives and negatives, know them. Combine like terms. All right, and then I'm going to solve. Canceled on both sides. Does negative 13 equal 42? No, so our answer is no solution. Super short, super sweet notes today, but everything applies to the same set of notes that we've been doing on just solving equations in general. Okay, you did turn in your worksheet today, so you do not have homework. You do have a quiz on all equations on Friday, so make sure you're looking over those each night. Okay, see you all tomorrow.